This lesson is about pyruvate oxidation, which is the second stage of cellular respiration. We start with pyruvate, which is the end product of glycolysis, and it needs to enter into the mitochondria through the membrane. And because it is a large molecule, what happens here is pyruvate translocase, transport protein, is used. And then after it enters, the carboxyl group is removed, which causes CO2 to be released. And then electrons and hydrogens are transferred to NAD plus to reduce it to NADH. Now you're wondering where the hydrogen atom came from? Well, it was initially pyruvic acid. It did have an H here. And that's where it initially got its hydrogen. And then remember, whenever you have a transfer of hydrogen, you have a dehydrogenase enzyme helping. And this is where this is pyruvate dehydrogenase right here. Shows the enzyme being used. The enzyme being used, pyruvate dehydrogenase, catalyzes the transfer of hydrogens. Next is coenzyme A, loses the hydrogen, and the remainder of it binds to the 2-carbon intermediate from pyruvate. And that's the resulting molecule is acetyl-CoA. So coenzyme A, after it lost its hydrogen, binded to the remainder 2-carbon molecule from pyruvate, resulting in acetyl-CoA. And now here's a worksheet for practice. One more thing. Now, since we get 2 molecules of pyruvate from 1 molecule of glucose, this cycle happens twice. This happens twice. And that's why the Krebs cycle happens twice. So, as you saw here before, we did get 2 molecules of NADH from glycolysis. We also got 2 molecules of NADH from the oxidation of pyruvate oxidation, since we get 2 molecules of pyruvate. And these, all these NADHs are going to the electron transport chain. And then here, we'll go to the worksheet for practice. Pyruvate enters the mitochondria using a transport chain. Using a transport protein, using a transport protein called pyruvate translocase. Then a blank is removed from pyruvate to form a blank as a byproduct. A decarboxyl group is removed from pyruvate to form carbon dioxide as a byproduct through the process of decarboxylation. I do have the answers here. I left them blank so you can practice. Pyruvate is oxidized and its electrons are transferred to NAD+ to reduce it with the help of the enzyme pyruvate dehydrogenase. And it's called pyruvate dehydrogenase because it transfers electrons and hydrogens from pyruvate. Coenzyme A loses an hydrogen atom, and the remainder of coenzyme A attaches to the 2-carbon intermediate, forming acetyl-CoA, the molecule needed for the next stage of cellular respiration. And this is the last slide for you to practice. This is the end of this lesson.